Hello everyone, thank you for attending a video conference meeting today. My name is Nahan. I'm a research professor at Eastern Michigan University. Here are co-authors of this research, Dr. Xu and Dr. Usher. I'm going to present my research topic, the effect of air distribution systems and building envelope design on indoor air quality and energy efficiency. The research focused on building-related issues about indoor air quality and energy that emphasize the need for sustainable building design and system because of considerable buildings' impacts on society, environment, community, and economy. Do you know how much energy is consumed in the U.S. commercial buildings? In 2018, the commercial buildings accounted for about 30% of total energy consumption. The major energy source is on electricity. Buildings consumed electricity to operate building systems, such as heating, ventilation, and air conditioning systems. Moreover, almost 30% of the new or renovated buildings caused indoor air problems because of inadequate ventilation and indoor chemical pollutants of buildings. The problems also contributed to building-associated illness. Based on issues and other researchers, building design and system were directly related to both of indoor air quality and energy efficiency because of buildings' energy performance. For these reasons, this research identified sustainable applications to building design and system was critical for improving energy performance of buildings. Sustainable buildings goals are society equity, environmental justice, community health, and quality of life. The research studied to find out different factors of combination of air system and building envelope design methods. For the purpose, the research used a building energy design and performance simulation software, Carrier's Hourly Analysis Program, HAP 5.11 version. This is contents of this experimental research. Statement of problem: facing the challenge of energy efficiency and indoor environmental health, building research professionals were prompted to formulate solutions to meet needs. The research problem of study was based on the fact that the effects of advanced air distribution system and enhanced building envelope design method on indoor air quality and energy performance in buildings had not been well addressed. Hypotheses and research questions. Based on understanding of the research problem and the related literature review, this research developed hypotheses and research questions. Hypothesis 1: Factors of advanced air distribution systems will be able to improve indoor air quality. Hypothesis 2: Factors of enhanced building envelope design will improve indoor air quality and energy efficiency. Research question 1: To what extent will air distribution systems affect indoor air quality and energy efficiency? Research question 2. To what extent will building envelope design factors affect indoor air quality and energy efficiency? This research map shows the study attempted to address the research hypotheses and questions. Building envelope and air system method were manipulated for testing indoor air quality and energy efficiency by using HAP research reports. Significance of the study. The study planned to investigate the effects of air system and building envelope design method for indoor air quality and energy efficiency of buildings. First, it emphasized enhanced building envelope design by comparing a measure of thermal resistance values of the walls and windows, R-value, solar heat gain coefficient, and/or U factors, and window-to-wall ratio. Then, it also emphasized advanced air distribution systems by comparing traditional and advanced systems, constant air volume and variable air volume. The purpose of the research was to approach to integrated building design and system regarding sustainable building goals. The objectives of research were to examine combination of building design and system methods to determine their impacts on indoor air quality and energy efficiency. It investigated building behavior and energy performance of heat flow and airflow in response to surrounding climate changes. It understood factors of energy performance for discovering indoor air quality and energy efficiency. Research design and type. The research used experimental analysis to explore modifications to the building air system and building envelope design method by developing whole building simulation model. It estimated indoor air quality and energy efficiency. The sample was classrooms and office areas within Seal Hall, an educational building at Eastern Michigan University. The pictures show the existing exterior wall conditions. The research used HAP as the data instrumentation. Data collection. The software ran energy simulations by inputting data sets for generating systems and energy reports to calculate heat gain loss and airflow rate. The research manipulated independent variables as causes for testing building performance. The experimental research made on software setting, then it conducted for testing variables and collecting data results. The diagram shows the experiment test procedures for the energy simulation. Existing air system CAV with existing envelope conditions. Existing air system CAV with envelope improvement 1. Existing air system CAV with envelope improvement 2. Advanced Air System VAV with Envelope Improvement 1. Advanced Air System VAV with Improvement 2. The research gathered data to enter data into the software HAP 5.11 and to generate energy design simulation result. Input data settings explained weather, walls, windows, spaces, and air systems. Weather data included information about the building location, summer and winter design temperature conditions, the local time zone, and the range of months of the design cooling calculation. For this research, July 1st was set as a simulation date. Wall data included information about construction material layers data. It showed total R value. R value was increased to R19 and R25. Window input data included information about construction material data, height, width, and SHGC U factors. SHGC U factors was decreased to 0.38 and 0.26. WWR was changed to 25% and 35% by adjusting window height and width. Space input data included information about floor area, ceiling height, and space usage and occupancy. Air system data included information of air distribution system (CAV) and VAV. The software generated system sizing data for building load. The slide shows air system data of constant air volume (CAV), about central heating, supply fan, zone, system sizing data of air distribution system type. Data result output data explained the energy design analysis of heat flow and air flow regarding indoor air quality. Data result explained energy use of building load regarding energy efficiency. The total number of experimental research test reports were 5 results. For analyzing the result of energy efficiency and indoor air quality, results were compared. This research demonstrated air system and building envelope method address heat flow and air flow. The amount of energy to be added, removed to keep an acceptable range of temperature. Address heat flow and air flow. The calculated load for the sample were listed number 1 to 9. The slide shows the calculated load number 1 to 9 of report 1 and 2. Then they were compared. For analyzing the result of energy efficiency, this research identified result values of design loads with steps. Result values were 1, 3, 8, and 9. CFM cubic feet per minute, a measurement of the velocity of air. MBH 1000 BTUs per hour, a measure of the amount of energy. The values of the amount of energy used were decreased. The energy efficiency was improved. For analyzing the result of indoor air quality, this research identified result values of design load with steps. Result values were 2, 4, 5, and 6. The values of the amount of air flow to maintain adequate ventilation and indoor air quality were decreased. The indoor air quality was improved. This research demonstrated air systems and the building envelope addressed airflow with air-water mixtures, the amount of air to be added, removed, to keep an acceptable range of airflow. Address airflow with air-water mixture. The calculated values of system psychometrics components were listed number 1 to 5. The slide shows the calculated values number 1 to 5 of report 1 and 2. Then they were compared. The values were shown on psychometrics chart. For analyzing the result of indoor air quality, this research identified result values of the calculated system psychometrics component with steps. The values of the amount of air flow and water vapor of air to maintain adequate ventilation and indoor air quality were decreased. The indoor air quality was improved because the system required less air to provide clean air to spaces by improving the building envelope. The system requires less air to circulate and manage air in spaces by improving air system. The CO2 carbon dioxide concentration levels decreased. The calculated values are shown on psychometric chart. Explained properties of air-water mixtures. Slopes were steeper than the previous result. Airflow was circulated well, in a less sensible heat-cool load, because air was cooled and dehumidified. Ranges of point were wider than the previous result. Managing different conditions of various spaces properly depend on the demands of those spaces to maintain adequate indoor air quality. The indoor air quality was improved. Under the proper cooling conditions, lower supply airflow speed was identified. Less airflow was required for maintaining air quality well, by supplying fresh air and managing temperature and humidity. Limitations of the study. The research focused on outdoor air intake to ensure carbon dioxide (CO2) concentration, air temperature, and relative humidity levels to meet building code requirement. Other indoor air quality issues of cost and chemical analysis were considered for the future research. Conclusions, findings. The modified properties of air distribution systems and building envelope design were examined to check the provided healthy indoor air quality and saved energy use in buildings. For identifying improved indoor air quality, the research showed decreased result of the calculated values of airflow. For identifying improved energy efficiency, this research showed decreased result of the calculated building load. This experimental result showed the significant changes from manipulated treatments, air system improvement, and building envelope improvements. For achieving improved indoor air quality and energy efficiency, building system and envelope design method were considered together, because when system and design method work as a partner, buildings further improved indoor air quality and reduced overall energy use. This research estimated the optimized building design and system method will result more significant changes in energy use, in building load, and indoor air quality in airflow rate of the tested building. Recommendations. The research suggested further research questions and hypotheses. By modifying air system and envelope design method regarding indoor air quality and energy efficiency. Further research will expand the range of independent variables by adding more improvement, higher R-value, lower solar heat gain coefficient, and manipulated window-to-wall ratio. Moreover, it will include energy recovery system as advanced air systems, and window shading systems as enhanced building envelope design. Thank you for taking your time to attend the presentation.